This video covers the 4th page of the Exam 2 review. Number 12, rationalize the denominator of each expression. Rationalize the denominator means to free up the radical in the denominator. And so I encourage you before you to do that to go ahead and simplify the radical. Square root of 20 is 4 times 5, so the square root of 20 is 2 square root of 5. The 2's cancel out, and you're left with 1 over square root 5. Now, when simplifying a square root, you only need 2 factors underneath the radical to free up the radical, so we need another 5 underneath there. We multiply top and bottom by square root 5. This is going to give us the square root of 5 over 5. In letter B, we simplify the root 75 first. This is 25 times 3. Square root 25 is 5. We have 1 3 under the radical. We need 1 more, so we multiply by root 3. It gives us 6 root 3 over 5 times root 9, which is 3. 3 goes into 3 once, into 6 twice, and we get 2 square root 3 over 5. Letter C, we have cubed roots this time, cubed root of 5 over cubed root of 18. I only want to put just enough underneath that radical, top and bottom, to free up the cubed root. 18 has 1 2 and 2 3's. I need another 2 2's and 1 3. So that's multiplying top and bottom by cube root of 12. In doing that, we ended up with 3 factors of 2, 3 factors of 3, which is going to leave us with a 6. The numerator is cube root of 5 times cube root of 12. That's the cube root of 60 divided by 6. When the denominator is a binomial, we use the conjugate of the denominator. That's what frees up its radical. We distribute the root 3 across and get 5 square root 3 plus square root of 3 times 6, which is 18, divided by 5 times 5 is 25. 5 root 6 minus 5 root 6 minus root 6 times root 6, which is 6. The numerator, square root 18, which is the square root of 9 times 2, or 3 square root of 2, plus 5 square root 3. Does not matter the order that you write that in. The denominator, these middle terms cancel, and 25 minus 6 is 19. Number 13, radical functions and their graphs. The domain is the set of x values for which the square root x plus 4 is a real number. Square root x plus 4 is real if x plus 4 is non-negative, greater than or equal to 0. So that'll give us x is greater than or equal to -4, or -4 to positive infinity. So what that tells me is that I'm going to get a graph from -4 to infinity here. That's a good starting point. Square root of -4 plus 4 is the square root of 0, which is 0. The next number that's going to be nice underneath the square root is going to be -3 plus 4, which is the square root of 1, which is 1. The next number that's nice after that is going to be the 0, because that gives you 0 plus 4, which is square root of 4, which is 2. Next number after that's going to be a 5, because that's going to give us the one with the 9, which is 3. And the next one after that is going to be the 12, which is going to give us the 16, which is 4. So 12 comma 4. Connecting those dots, graph looks something like that. We see that the 21 is going to be the one that gets us up to 5. And now the range of it, we see that the graph goes from 0 to positive infinity. Graphing the square root x minus 2, its domain is such that square root x is real. And that's real when just the radicand is greater than or equal to 0. So we get this one goes from 0 to infinity. We're going to get a graph from 0 to infinity. That means 0 is a good starting point. And we get 0 minus 2, which is -2, or 0, -2. 1 is going to be the next nice number to choose. Square root 1 minus 2 is 1 minus 2, which is -1. 4 is a good number to plug in. Square root 4 minus 2 is 2 minus 2, which is 0. And 9 is a good number to plug in. Square root 9 minus 2, which is 3 minus 2, which is 1. 16 is the next nice number. Square root 16 minus 2 is 4 minus 2, which is 2. 16, 2. Based on the graph, determine the range. We see here that the graph starts with y values of -2 and goes up from there, giving us a range of -2 to positive infinity.